Okay, right. Thanks everyone for joining. I'm going to be presenting on our remote sensing capabilities for infrastructure, and just kind of give a little bit of an overview of the different services that we can offer from aerial photography and LiDAR, and some of the applications for infrastructure. There'll be time for questions and comments at the end. So if you can hold your questions for now, that'd be great. So I'll get into the detail pretty quickly, really, but just a couple of very brief introductory slides. My name is David Campbell. I'm an associate director at APEM. I've been with the company about 15 years, and I head up our remote sensing consultancy team. We have a team of around 25 people in the remote sensing department. They are ranging from people who go out into the aircraft to collect the data, through to processors and consultants and report writers. APEM as a whole, for those who aren't familiar with us, we focus on the water industry and the utilities industry quite heavily, and we kind of service everything from kind of the upland catchments through down to the sea, kind of, and everything that happens in between, really. We've got consultants that are terrestrial ecologists, fishery scientists. We have a marine team that look at offshore wind farms, but we also have this quite large remote sensing team that focuses on aerial photography for a range of clients, and what the ones I'm talking about today is going to be the ones where we focus on infrastructure. Got a number of offices dotted around the UK and Ireland, around 180 staff as a company as a whole. We also have quite a large presence in the States, a lot of surveys going on over there, and we also survey in Australia. So we have kind of a global reach, but we have most of our work is done in kind of the UK and Ireland. And some of the things we're going to be able to cover that kind of went out in the email introductions: how we can collect topographic data, pre and post construction condition assessments, virtual health and safety site assessments and site inductions, and the 3D photorealistic environment that we can create from 3D imaging. And I'll show you a kind of a live demo of that towards the end of the presentation, so you really get a feel for how that can work and how it can benefit, hopefully, some of your projects. Okay, so into the detail. So I'll just start with giving an overview of the different types of data that can be generated from aerial imagery. The first one is topographic surveys from photogrammetry. So photogrammetry is essentially an image-based product. So it's overlapping imagery that would cover the landscape, and because it's overlapping, the stereo image, you can convert it into height data. So we can create orthomosaics that are very precisely tied into ordnance datum, but we can also generate elevation from that. So we can generate a height model that the imagery can be overlaid on. So photogrammetry is one of the data types that we collect from aerial imagery. The other one's LiDAR. LiDAR is an active sensor. It's a laser that comes out from the hull of the aircraft that kind of pings the landscape, gets very accurate positional returns from those returns from the lasers, that generates a point cloud of the landscape, essentially. And main differences between generating topography from photogrammetry from LiDAR is that LiDAR can punch through the tree canopy, so we can get returns from the ground surface below a tree canopy, whereas photogrammetry can't. But there's other benefits going the other way, and I'll kind of tease them out as we go. And the third type of data that we can collect is that it's not just color imagery. We can go into other parts of the electromagnetic spectrum as well. So this is a color imagery image of a water company treatment site. And if I show the near infrared version of that, you can see it looks quite different. So near infrared is beyond the visible spectrum, and it's very sensitive to changes in vegetation. So where you get very strong, healthy vegetation, you get those bright reds and pinks that you can see. Where there isn't any when there isn't any vegetation, or there's very water stressed vegetation, for example, you get those kind of blue, green, washed out colours. So that's why this was taken in winter. So some of the trees are very grey-green, apart from there's a couple of trees you might be able to point out that are probably evergreen trees, and that's why they're showing bright red. So that's useful in some of our analysis and habitat classifications, to have that near infrared layer that shows the differences in vegetation, as well as that colour imagery, and the data are collected at the same time. We can also collect thermal imagery, and that's an example of a thermal data set. So it's obviously showing the temperature of the landscape. Again, same site. Just as an example, this was done for purposes of looking at heat loss from different parts of the site, but also other things were teased out from that. For example, the temperature of the filter beds there, and those circular constructions in the middle of the image there. There's those bank of circles on the filter beds, and the one on the bottom left was a different temperature from the other ones, and that kind of highlighted there was an operational problem with that filter bed that they didn't know before for the operational managers of that site. So lots of information can be teased out from thermal imagery, as well as the colour in the near infrared. So what do we do with those data sets? Well, firstly, topographic data is what we're often asked to create surveys and survey designs for. It could be for new pipe routes, it could be for new electricity cable routes, it could be for a new construction site where it's important to understand the topography of the site. And aerial imagery is a good way of getting up there and surveying big areas in a very short space of time. Might be a problem with land access, so that's often why we're asked to go, that you can't necessarily get teams out on the ground. So we would use either photogrammetry or LiDAR, or in some cases a combination of the two. And then we're providing high density point clouds, digital surface models, and digital terrain models. The difference between the two is the surface models contain all the surface features of the landscape, so trees, buildings, etc. are included in that high model. Digital terrain model is with all those surface features stripped out, so you just kind of get that bare earth layer. And if there's vegetation around, then that's where it's useful to have the LiDAR technology as part of that as well, because we can punch through the tree canopy and get data from the ground level. Elevation maps, ASCII grid files, contour maps are often what we're asked for to do, and the reality meshes and the VR ready virtual fly-throughs, those are creating a 3D environment that we can navigate around, and I'll show the examples of that towards the end of the presentation. And a couple of examples of contour maps. Sometimes it's as simple as we're doing land cover, and the outputs are contours, which is kind of akin to what's generated from on the ground, but this is generated from the air. The difference being that on the ground you're probably looking at the break lines when measuring the topography. Here we are sampling the earth with LiDAR, kind of 10+ points per square meter. So there's literally over a survey area, there's millions upon millions of data sets that the contours were created from. So in terms of the detail, really picking up those small undulations in the landscape, and this is a great method for it. I'll come back to visualizations for stakeholder engagement as part of the 3D data set. So an example of where we did this was for a road project. This was up in Scotland a couple of years ago, and there was a bypass around Aberdeen. It was just under 60 kilometres in length, and because of the speed at which they were trying to survey everything that was going on in the construction site, all the excavated material, it wasn't practical to rely on ground surveys at that scale. There had been too many topographic surveys that would be needed to be on site at the same time as heavy plant moving around excavating material. So they wanted to remove the survey aspect of it from the ground and put that into the air. There were those safety concerns and the timescales as well. It was being developed concurrently over the whole site, so the time to get all the data from the ground teams wasn't something that was practical. Obviously, they wanted to kind of manage the costs as well. So what we did was we surveyed the site. That 58 kilometres was surveyed in around 6 hours. This is with a manned aircraft. This isn't with a drone, by the way. This is with manned aircraft with sensors fixed into the aircraft. Download the imagery, produce the continuous orthomosaic, those high density surface models, and those 3D models of the site were then created. And it generated very accurate topographic data, and that could be used by the engineers for earthworks calculations. And that's what for this one, that was one of the primary aims of the project, was to have a look at how much excavated material there was, and in terms of how many lorries do they need to order to remove that material. And that was, once we've got the 3D model, very easy to extract that type of information from the data set. And also looking at the construction phasing and how it's been developed. So this was an example of the site as it was being generated. That's an example of the detail of the imagery. This was a 5 centimetre or 7 centimetre resolution data. We can go a lot higher, a lot more detailed than this, but for the purposes of this, they wanted to go at 5 to 7 centimetre resolution data. So that's what the data quality was like along the 60 kilometres. And then looking at the kind of the development of the site as things change. There's some excavated material on that bottom, that square to the right, and then because we were doing this repeatedly, we were able to build up that information database of the kind of the construction phasing and how things were being developed. So that was one example. Another aspect that we're often asked to go out and survey for is pipe mapping and leak detection. It's generally for water companies that we're asked to do that for, and we either go out with the thermal or the near infrared data. And what we're doing there is we're surveying, again with fixed wing manned aircraft. We're flying along the pipe routes and collecting data. In the winter, we use thermal data to look at that, because we're looking at the temperature differential between a potential leak and very cool surrounding ground. So we go on a cold, dry night in winter, and then the differences in temperature from a leak versus the ambient surrounding temperature we can see in the data. In the summer, we go with the near infrared, and that was when I was mentioning about the difference in change in vegetation response in the near infrared. When there's a leak in the summer, the ground, the vegetation stays enriched with water. And if we go during the dry period, the background information, the background environment is slightly water stressed. So those kind of well watered patches of vegetation show up really brightly in the near infrared. So that's how we use the method in the summer to look at leakage. We can often also look at the route of the pipes and map those if needed. And sometimes we're asked to help find the route of the pipe, and that can be seen either sometimes through the thermal imagery, but often just through the high resolution data set, looking at valves, looking at disturbances to the earth and the slight changes in vegetation that you get because there's a pipe underneath the surface. Vegetation encroachment and invasive species, something that we look at as well. We're looking at very high resolution data sets in 3 dimensions, and I should also say that we don't just collect imagery in the vertical. We also have an array of cameras on our aircraft that capture data obliquely as well. So we're looking, we can see the sides of the buildings and the sides of tree structures as well. So when we're looking at vegetation encroachment, perhaps along a road, that's something that we can develop into a 3D model and able to see that. We can also look at that plant vegetation health and vigor, looking at stressed trees, which ones might be at risk of falling onto a carriageway, for example, and that's shown up through that near infrared imagery. Species identification and invasive species mapping. Japanese knotweed is a big problem. If we go at the right time of year in late summer, we can see that the resolution is such that we can see the Japanese knotweed and Himalayan balsam, for example, and be able to undertake species identification and see the extent of that species. And often that's important when you're not just looking along your asset corridor. You might want to look kind of left and right of that to see if there's a bank of Japanese knotweed that's kind of spreading and it's about to impact on your asset. Really important to know, and aerial photography can get that view of not just your asset but what's happening either side of it that may impact on that. Overhead line equipment mapping, that's something that often LiDAR and sometimes photogrammetry is used for. And that's looking at very high resolution point cloud data to pick out the overhead lines, but also the vegetation surrounding that, looking at vegetation encroachment. So this is an example of how you can use a LiDAR point cloud and classify it into different areas. So when the LiDAR is pinging over the landscape, it's generating returns from everything, really. It's from the vegetation, it's from the ground, it's from buildings, it's from the power cables, and we can then classify all those point clouds into useful features that we can turn into maps. So, for example, we could classify the ground and strip everything out, strip all the vegetation, the overhead power lines out, and just show us what the bare earth is. And those are the ground points there that we're getting from the LiDAR. We can pick out the overhead line points as a separate layer. We can pick up the low vegetation and also the tall vegetation, the trees, and they can all be classified as different points in the point cloud, and then we can start to look at proximity analysis to overhead power lines, for example. So when it comes to looking at that in terms of power lines, the kind of traditional way is to go out on the ground and survey along spans of electricity cables, looking at on the ground measurements, etc. Essentially, with the aircraft, you can classify the vegetation, you know the location of the power line, so you can essentially do that risk in a 3D environment. And pick out which trees are at risk of falling. The falling arc of the trees might intersect with the power lines, for example. So again, it's about mapping the landscape, generating a digital environment of which you can then go in and do all sorts of different analysis that you could do out in the field, but you're doing it from the office, and you're getting that fuller data set. Land cover and habitat classification. We're often asked to do a land cover and habitat assessment as part of a new infrastructure development. So if it's a new power cable route, for example, when undertaking route selection, the power company will want to know what's going to have the least impact from an ecological point of view, but also what land it's going over and what issues they might have to encounter along the way. So surveying that, classifying that into land cover, so kind of improved grassland, forest, water, agricultural land, etc. That's a key output for the ecologists and for the planning teams, and that will inform perhaps which route they take, but also will inform where to target the ground teams, the ground ecologists. I'm not saying that this is replacing ground teams completely. This is complementing them and targeting them. And there's an example for a new pipe route that the ecologists needed to go out and survey all the ponds in the area for newts, but they weren't sure where all the ponds were. So carrying out an aerial imaging survey of that to identify all the ponds along the route was a very quick way of being able to target the ground teams to go out and do the newt surveys that they needed to be done during a specific seasonal window. Otherwise, they would have had to wait for a whole year till the next seasonal window, which would have put the program back by a year. So getting a survey done earlier on in the program really accelerated the whole thing, and that's what we often see. That's a 3D representation of the habitat map. And looking at change, if we do repeat surveys, it is something that we do as well. Looking at change in the landscape and looking at monitoring restoration response as well. There's a survey, this was actually from the Everglades. I've mentioned that we do a lot of surveys in the States as well. This was an area where habitat was being improved, vegetation was being planted, and we were tracking that. Well, we still are tracking that. We've been doing that for about 7 years now, where we've surveyed and looking at changes in the landscape and how vegetation is coming back due to the kind of that managed land processes that are going on. And just high resolution imagery for looking at assets is something that we do. It's not just the vertical imagery that we get. As I say, we have this array of imagery and we collect oblique data as well. And yeah, that's an example. I think that's a gas processing station that we surveyed. And I'll show you some more example images shortly. They don't always come as through quite as cleanly on the PowerPoint presentation. But anyway, these images are around kind of 3 centimeter resolution. So that's every pixel represents 3 centimeters on the ground. Again, often fixed wing aerial photography rather than drones, which means that we're collecting the detail that a drone could get, but over the scale that a manned aircraft can get. Okay, so I'm going to come out of the presentation. And I'm just going to show you a couple of examples of the data that we create. So firstly, I'll show you what a 2 centimeter resolution looks like and the detail that we can get with that, because that's what we're often being asked to go out and survey at the moment. So this is a treatment facility. So if I zoom in, you can see what kind of level of detail you get at 2 centimeters. So obviously, picking out a couple of things, temporary fencing there, you can easily pick that out. Details of pipes, etc. Handrails across the walkway there. And if I just move over to kind of a back garden setting, just to give you a different context, we're seeing the washing line, and it's picking up that level of detail. In terms of the detail of vegetation, that's the sort of information that we're getting that we can start producing those habitat maps from. So again, if that scale of information would be useful on your local asset, individual site-by-site basis, or kind of across big areas, a whole new linear routes. For example, that's what can be achieved through aerial imaging. And a 3D data set I'll show you. This is an example of this is available online. So we start with the kind of the top-down two-dimensional view, which is I suppose the data sets that people are most familiar with, perhaps. But we can turn that into the 3 dimensions, and because we have those oblique imagery collecting data from the sides of the building, we can pick up data from the sides of the buildings as well. And when I was talking before about looking at excavated material, this is what's available in the 3 dimensions, and we could draw a polygon around that and get some information from that. We can measure heights of buildings, we can measure distances between sites. Sometimes we're asked to go from a health and safety point of view for a site to look at where's safe to park vehicles, where are the slopes, where's the turning circles on vehicles, and get up-to-date information from that, and kind of do virtual health and safety site visits from it. I'll just pick up a couple of other interesting things from an infrastructure point of view on this data set. This data set was used for a whole range of ecological and infrastructure aspects, but looking at pipe routes, for example. So I mentioned before that you can often see the route of a pipe because of changes in vegetation at the surface. Well, this kind of linear feature, this was a pipe, and you can see the valve lids junction point there, and that change in vegetation there is probably that's leaking as well. And let's just go to prove it was a pipe, that you could see there's the pipe crossing point there. A lot of the time we're looking at from a catchment perspective, we're looking at diffuse pollution and problems in the catchment from a kind of a land practice problems, causing problems for the water, but also outflows into the water, into the rivers as well. And there's an example, let's see if I can find it there, where you can see there's clearly an outfall coming from there that was causing problems from the river, and that was something that the water company didn't know about, so that was picked up from the aerial imagery. Looking at biodiversity and natural capital, this provides the bulk of the information that you would need to do that biodiversity assessment from this, because you can see what the vegetation is, you can see the location, the proximity to other features, and also the height and the volume of trees and hedgerows, etc. So it would be possible to create a biodiversity assessment from this data set as well. And then the last thing I wanted to show you was how we use the data from a stakeholder engagement perspective. So this was a 3D model that we created, and this was used for a new development of a new cable route that was going into an area. This was from an offshore wind farm that needed to be connected to the local grid. So we photographed it in stereo, created a 3D model of it, and then we could start overlaying features. So the yellow is the site boundary, the purple is the new cable routes, and everything else is photorealistic 3D models. And this was taken to stakeholder engagement events to kind of show the public what was going to be installed. Everything there is real, apart from the power station, which comes from the design drawings that's overlaid on the 3D model. And And the other thing that's dropped in there that isn't from the imagery are these kind of slightly different coloured vegetation that are around here. So that was part of the vegetation management to sort of screen the substation. And it was taken to public supply days to local residents, and they could move around the model. This is a fly through. We recorded this, but this was available in real time, and we could sit down with the local residents and say, well, okay, what's it going to look like from your house? What's it going to look like from your upstairs bedroom window, or from where you walk your dog? And we could just zoom around to see what change it would look like from their points of interest. And just this next one there is an example of these trees that are coming along here. Those are part of the screening, and then people could see, you know, what that was going to look like from their perspective. So that is kind of the end of the presentation. Just a quick summary: high resolution mapping, topography surveys, looking at 3D modelling and earthworks calculation, looking at assets, looking at vegetation proximity, habitat and land cover mapping, and then those visualising the site remotely for stakeholder engagement. So I'll stop sharing my screen at that point, and yeah, just open up the floor to see if there's any questions or comments. If anybody's got any. I'll leave it a couple of minutes. So if there is anything, this. I believe we're going to send this recording round. If this kind of sort of piqued anybody's interest and they've got some projects coming up that they would be interested in having an idea of, you know, kind of what would this survey do for you, then, you know, please get in touch and we can discuss what might be possible. These are just a few examples that I've shown you here. Often people come to us to sort of say, well, I want to get this out of it. What can you do? So, you know, what I've shown there isn't the bounds of what you can get out of the imagery. You know, I'd encourage you to sort of think creatively and think, well, could an aerial survey be of interest, a part of our project? So yeah, do get in touch if there's any questions. There's something in the chat. There was a question there: what formats can you export 3D data models in? So the point clouds are typically exported in .las format. The 3D models are typically .obj files. They do integrate with CAD. They integrate with the Bentley software. In fact, the data that we're creating is Bentley software, so they integrate kind of seamlessly with those. And we often integrate it with our clients' needs. So if there is a particular format that you need your 3D model to be created in, you know, drop me a line and I'll speak to our technical experts and get back to you to see if we can do that. Any other thoughts or questions before we draw it to a close there? No? Okay. All right. Well, thank you very much for your time. Hopefully it was an interesting kind of half an hour, 45 minutes. And as I say, please feel free to get in touch with any further comments or questions, or if you want us to kind of cost anything up. All right. Thank you, everybody, and enjoy the rest of your day.